Saxon Algebra 2, Lesson 46. We're going to talk about radicals. Let's just dive in. No preamble necessary. Oh, I'm sorry. I was ready to go to the second example. Lesson 1. Simplify. Now I'm going to write them down the way that John writes them down, and then I'm going to tell you what I don't like about it and how I would do it in my homework if I was you. Okay, he's writing these numbers with a big floaty number and then a fraction inside a pig house. Big floaty number, fraction in a pig house. This one looks fine to me. This, I don't like this at all. So what we're going to do is change the presentation. I want the whole number and the top of the fraction in its own pig house over the bottom. Does that make sense? Okay, so the whole number and the top in its own radical sign over the bottom. And then this is fine. We can copy that. All right. John writes a lot of problems that look more or less like this. I think, have we been doing them? I think we have been. But what we're going to do is we're going to fix these two first, and then we'll deal with this. Because these two have a pressing problem. They have irrational denominators, and we can't live with that. So what we're going to do is rationalize the denominators by multiplying top and bottom by whatever's in the bottom. Because we know that this will equal any number in a square root of any pig times the same pig. They'll jump out and turn into one on the outside, right? That's what I'm trying to say. So these will become a 7 on the outside. And then remember, we multiply pig to pig, wolf to wolf. So this will be 3 square root of 14 minus, and then we'll have 5 square root of 14 up there. That's interesting, right? And then on the bottom, these two pigs will give us a 2 on the outside. And then we copy this. Nothing interesting is happening over there yet, right? But let's look at that. 56 is a pretty big number for being inside a pig house. I wonder if we can prime factor that and get some pigs out of there. So let's take a look. 56 is 7 times 8, but 8 I know is 2 cubed. So I'm just going to do it all in one fell swoop, right? There's 7 times 8. Those 3 make 8. These are all prime. And I see, oh yeah, there's a pair of pigs I can pull out. That'll give me a 2 out here. I'll multiply it by the 3, and then I'm left with those in here. So let's write it again. 3 square root of 14 over 7. And then let's see, how did I do this? It's 2 times 3 on the outside, that's 6. And then what's left inside? 7 times 2, right? Because there's the 2 I took out. Oh, look what happened. They all match now. John. He's a buddy and a pal. So now what can we do? Well, we've got all our radical signs under control. They all match, but we can't add them together because we have denominator drama. Ugh, those denominators, they are trouble, aren't they? So what do we do to mush them together? Well, we have to LCM the heck out of them and then adjust. There's no equal sign in sight, so it's just an expression. So we're multiplying each one top and bottom. All right, what's our LCM? 7, 2, and that's 1. So 14, right? 14 works. Let me use another color to do my adjusting. Let's see. We want to end up with 14. So this one will be 2 over 2. And this one will be 7 over 7. And this one we have to do the whole thing, right? 14 over 14. Interesting that our LCM is equal to the number in the radical sign. That's just a coincidence, but it's kind of weird, isn't it? All right, so then we multiply. Remember, wolves times wolves, so that's 6 square root of 14 over 14 minus 35 square root of 14 over 14 plus land of Goshen. 14 times 6, I'll do right here. 84 square root of 14 over 14. Now all the denominators match and all the radicals match. So now we can just do 6 minus 35 plus 84. Oh my gosh, life is so good, right? So I'm going to add together the two positives because that makes a nice 90, and then subtract the 35, and that is what, 55, right? So our final answer is positive 55, and then all the rest just comes along for the ride. Woo! That's a lot, but we did it, right? So first, we rationalize the denominators. Then, over here, we simplified the radical. And then here, we made the denominators match. Three steps, all right? And while there is some subjectivity of the order that you do those in, I highly recommend this order, all right? You definitely need to do all three steps, but that's the right way to approach it. It minimizes the amount of work you have to do. And I'm all for that, right? Okay, so that is part of what we wanted to talk about with the radicals, but there's something else I need to tell you, and I need you to buckle your seatbelt because it's a little bit crazy. We've talked about fractional exponents. By the way, I think the purple marker has faded. Let's see. I bought a bunch of new markers at the beginning of the school year, and I'm down to almost none. Look, I'll show you the colors I have left. I had like 64 markers, and this is what I'm down to. So you're going to get some, I got to get through this last week, right? But I don't know, I might just break down and buy more. Okay, we know that fractional exponents are a way of stating radicals without actually using a radical sign. And they're nice because they're easier to combine, because here they're exponents and we can just use our rules of exponent, product, quotient, and power, if you will. So this is cute, and I'm all for the three little pigs and all, but this is more effective, and it's more, it's a more sophisticated way. It's a more sophisticated notation, and we're going to start to wean ourselves from using this all the time to this. And remember that it's the little number up here that goes in the denominator of the fraction of the exponent. That's an exponent. These are both exponents. They're big. And remember, when we don't have a number in the corner, it's an invisible 2. Okay, so we're going to use that information to deal with these problems. And most students feel like they've gotten slapped across the face when they first see these, because they're like, what are you talking about? It's a pig house in a pig house. What in the world? It's like Next Generation, Three Little Pigs. I'm not even going to try to build a metaphor for that. What I'm going to do is I'm going to convert the innermost pig house to parentheses with an exponent. So I'm going to leave the outside alone because even I don't like to borrow trouble. I'm going to change this pig house into parentheses, and I'm going to put the pig in there, and then I'm going to give him an exponent. Okay, so first I did the innermost pig. Now I'm going to do the outermost pig. All right, so now it becomes parentheses around him, but this I can just copy. But now I need this 1/2 because that represents this. Does that make sense? The inner one is written here. outer one is written there. Now I'm ready to use my power rule, which says if you're taking one exponent and raising it to a higher power, you multiply those two together. So now I know this has got a 1 on it, right? Because there's no exponent there. So I can multiply times that and times that. So my almost final answer is 3 to the 1/2, because 1 times 1/2 is 1/2, times 3 to the 1/4. 1/2 times 1/2 is 1/4. All right, we're almost there. We used the power rule to simplify. Now, what about the product rule? If we're multiplying matching bases, we add the exponents. Look, we're multiplying matching bases. We have to add the exponents. To add fractions, the denominators have to match. This is equal to 2 over 4. Now we can add them. Our final answer is 3 to the 3/4 power. What on earth is this madness? But you can do it. Just go to the innermost pig house, convert it into parentheses, and give him his little exponent. Put the exponent on the inside whenever possible, the inside of the parentheses, because we just have the one little base there. It's fine to do that. Then when you convert the outer pig house, just copy all that just the way it is into the bigger pig house. It's nutty, but it works. Let's try another one. There are 3 more problems. All right, this one's really similar. This marker's had it. I'll go to the brown. Ready? 46.3. It looks quite a bit like this one, except this time we've got a 3 on the outside. All right, so let's practice it. First, we take the innermost pig house, we put parentheses around it, and rewrite it as a fractional exponent. So this outside stuff stays the same. But this becomes 3 to the 1/2, because there's no number there, so it's an automatic 2. All right, I like it. Now we'll do the outer pig house. And that's 3 times 3 to the 1/2. But this pig, and we have to put this exponent on the outside, right? This one goes on the inside because it's just the exponent in the 3. They're fine together. But now when we go to put the 1/3 on it, it's more confusing. So we have to put parentheses around the whole thing. That reminds us that we have to distribute it to both bases. That's another way to say it. When we put the fractional exponent on just this 3, it's really simple. It's just the 3. But when we go to put the exponent on this bigger chunk, it's too confusing, so we put more parentheses around it. Okay, I put the 1 there to remind me that I'm multiplying, right? So it's 3 to the 1/3 times 3 to the 1/6. The denominators have to match, so this will become 3 over 6, right? I can do that in my head. Oh, wait. 2 over 6. I was thinking about the answer. Now we can add them. It's 3 to the 3/6, and that equals 3 to the 1/2. Final answer. Just when the dust starts to settle in your brain and you think, all right, I can manage it, we're going to do something more. Ready? I mean, I know you're not. This is hard. This makes most students' brains go all mushy. Simplify. Okay, we haven't done anything that looks like that, have we? Where there's exponents in here and letters. Oh, that looks hard. Okay, but look, there's more. All right. Let's just break it down and go slow and see what happens. We remember our basic strategy is that we turn pig houses, convert to parentheses. That's our basic strategy, you guys. So this is a square root, so we're going to turn this whole thing. We're going to put the guts of the pig house into parentheses, and we're going to raise it to the 1/2. All right, that wasn't horrible. Let's do the same thing over here. X, y to the 7th, and then that goes out there. All right, now we use the power rule. We're going to distribute that 1/2. I'm going to put a 1 on that guy because he doesn't have an exponent. And we're multiplying, so it becomes x. Now look what happens. When we multiply 3 times 1/2, we get 3/2. Oh my gosh, now we have numbers in the top. Oh, it's so weird, right? But look what happens to y. 2 times 1/2, it just becomes 1, right? Because 2 times 1/2 is 2/2, which is equal to 1. So I'm just going to leave it like that. Now, what's going on over here? Now we have x to the 1/3, 1 times 1/3, and y to the 7/3. Take just a minute. If you're even remotely following this, I mean, if you're not remotely following it, stop and rewind. But if you're even remotely following this, just take a look at how flippin' hard that looks. It's impressive that you're understanding it at all. All right, now we're ready to product rule and combine the exponents for the matching basis. So let's just write this out a little bit more. For x, we want to add 3/2 plus 1/3, right? So we have to do least common multiple. So that's going to be 6, right? So this one will multiply by 3/3, and this one by 2/2, which will give us 9/6 plus 2/6, which equals 11/6. Yikes. Okay, we'll just leave it at that. And then with our y's, we're going to do 1 plus 7/3. Okay, we'll just change this into 3/3. And then that gives us 10/3. And so our final answer is x to the 11/6 and y to the 10/3. Feel smart. That's hard. That's hard stuff. And we have one more to go. Ready? Don't faint yet. Tonight I watched this. I've been watching this. It's on Netflix. It's called The Valhalla Murders. You've probably seen it. It's been in the trending. It's cool. It's set in Iceland, and it's a detective show. And so our police detective hero lady, I saw the last episode tonight, and so she's in the situation where she's confronted, or she's gone to what she thought was a good guy, but he actually turned out to be the bad guy. And so she's at his house alone at night, and he's drugged her, and she's passed out. And he's going to kill her, but he's going through a step-by-step process. But what was hilarious is that she'd be lying there dead and passed out, and then he would be, getting ready to move her to the next place. And she would suddenly wake up and bonk him over the head with a wrench and then pass back out again. And then he'd come to and do something else, and then she'd wake up and stab him with something else. She just kept like springing to life. And I think that's what I'm saying, is that we're just going to spring to life one more time here with example 46.5. I kind of lost track of my tie-in there because I got really excited telling you that story. But I'm kind of I've been watching a lot of Scandinavian police dramas. It's quite a genre, isn't it? But I'll tell you one reason why I like to do it. They have really nice interiors. And I like to look at the way they style all the rooms and the way they do the lighting. It's very hygge, and I'm into it. So I think that's a big reason why I like them. I like the interiors. Okay, here we go. Ready? This one looks kind of like the last one we just did. It doesn't have little pigs and big pigs. It just has big pig houses and then exponents in here. So we're going to approach it like we did last time. We turn pig houses into parentheses. You know, they talk about beating swords into plowshares. That's what I always think. We're beating our pig houses into parentheses. So, you know, if that helps, go for it. All right, so this turns into a 1/3, right? And then we write the little piggies. And then we do the same thing here. Parentheses into pig house. Take that number and make a fraction. Copy the little pigs. Oh, crazy 7 dreams. All right, this guy doesn't have an exponent, so let's give him a 1. And then we distribute. Okay, now we multiply. X to the 5/3. Y, 3 times 1/3 is 1. X to the 1/4. Y to the 5/4. All right. I like it. Now let's do the same thing. Let's sort out our exponents. 5/3 and 1/4. I'm going to spread those out. LCM 12. So 4/4. 3/3. So we get 20/12 plus 3/12 equals 23/12. That's a tongue twister. And for the y's, it's 1 plus 5/4. Okay, we can just, these are easy to fix, right? We can just convert that to 4/4. So then we get 9/4. And our final answer then is x to the 23/12 plus, oh no, not plus, times, we're multiplying all of this, times y to the 9/4. There's no addition anywhere in sight other than just using the product rule here. That's what threw me off. But what we're doing with all of these guys is multiplying everything in sight. All right? This is our correct answer. Yes, it is. Feel smart. Those are hard. Remember to show your work just the way I'm showing mine. That's the best way you can prepare for the midterm, which is coming up fast. Make sure, especially in these problems, give me lots of white space around and make it big so that I can see your exponents clearly. If you tried to write y to the 5/4 in a single line, it would be hard for me to even tell that was an exponent. Give me room so I can see what you're writing. Thank you, lesson 46. Thank you, students, for your rapt attention. And I will see you for 47.